Welcome to a new video. In this video, I will explain you what is the pin diagram of 8051 microcontroller. In one of my previous videos, you have seen 8051. I have shown you that 8051 IC. So in this video, I am going to explain you what are the different pins which are available to that 8051 IC. This is the 8051 IC we have seen in the last classes. I have shown you this one. So today we are going to see what are these 40 pins. It is having 40 pins. So I am going to explain you what are the uses of these 40 pins, so that we can use this IC in our designs. So as I mentioned, this is an IC which is having 40 pins. So an IC which is having pins on both sides, we already know it is called as a dual inline package. So this 8051 microcontroller is available as dual inline package. You can see in the pin diagram here. We will see in a closer view after completing the explanation part. So for 20 pins are there on one side and 20 pins are there on other side. So that's why it is called as dual inline package. Pins and IC which is having pins on both sides. Otherwise, an IC which is having pins on four sides is called as quad pack. Like that, different packages are available. So the IC which is available with us, it is manufactured by HANU7. So it is having pins on both sides. So it's a dual inline package. We will call it as DIP. So there are 40 pins. Out of this 40 pins, 32 pins are input-output lines only. So we know that in the features of 8051 that we came to know that 8051 is a microcontroller which is having on-chip input and output pins. Or otherwise we can say it is having 32 input-output lines available on chip. It is having 4 kilobytes of ROM memory and 128 bytes of RAM memory. Okay, so these 32 input-output lines are available as pins in the IC itself. So out of 40 pins, 32 pins are input-output lines which are available as 4 ports. These 32 pins are configured as 4 ports. One is port 0, port 1, port 2 and port 3. So totally these 32 pins which are input and output pins, they are configured as 4 ports. So we can say that there are 4 IO ports available for the microcontroller 8051. And after apart from this 32 other pins, what are the other pins are? We have one pin which is plus 5 volts input to the device. This device is a TTL compatible device. We have to provide plus 5 volts as an input, and other pin is ground, and we have a reset pin. So I can say these 3 are power supply pins. These are the 3 pins. 3 pins are power supply pins. And we know that every CPU, every processor or every controller requires CPU clock frequency. So in order to provide the CPU clock frequency, we will connect a crystal oscillator to the microcontroller 8051. So we have 2 pins dedicated for that. They are called as crystal pins. 2 pins are crystal oscillator pins. So we can connect crystal oscillator through these 2 pins. So how many are over? 32 plus 3 plus 2. Total 37 pins are over. So we are left with only 3 pins. So those 3 pins are called special pins of this 8051. One is EA bar, and second one is ALE, and the third one is PSEN bar. One is EA bar / VPP, other one is ELE and PSEN bar. These 3 are the very important pins. I will explain you in the pin diagram what is the use of these 3 pins. So you look at the count now. 32 input-output lines are there. They are configured as 4 ports. Then 3 are power supply pins, 2 are crystal pins, and I have to remember hardly 3 pins only: EA bar / VPP, ALE and PSEN bar. So it's very easy for us to draw this pin diagram of 8051. So if you draw it roughly, you can see here. I mentioned there are 32 input-output lines. They are configured as 4 ports. So for a IC, if you put the notch towards top side, then you have to identify that this is pin number 1. and this is pin number 40. So this is one thing you have to remember. Put the notch towards the top side. So for this IC there is a notch here. Put this notch towards top side. Then you can see that this is pin number 1 and this is pin number 40. Okay. So similarly like that up to here we will have 20 and 21 to 40. So in these 40 pins, as I mentioned that 32 pins are input output lines, they are configured as 4 ports. So port 0 is available here and port 2 is available here. Even numbers, you can remember like this. Even numbers are available on one side and odd numbers P1 and P3 are available on the other side. So P1 is available here, P3 is available here, P0, P2. Exactly where they are, I will tell you in this diagram. So roughly I am telling how to draw the pin diagram. So 32 pins are over. How many pins are left? 5 more pins. They are power supply pins and then crystal oscillator pins. VCC is the power supply pin. In maximum ICs, VCC will be 48, 20 is the ground and here 9 is the reset. And here we have crystal pins, 18th and 19th. So 32 plus 5, 37 over. And the rest of the 3 pins which are left out, there you have to put these 3. EA bar slash VPP, ALE, PSC and bar. Now let us see how to locate exactly these pins. As I told just now, out of 40 pins, 32 are the input output pins. So they are arranged as 4 ports. You can see port number 1 is here. P1.0 to P1.7 are from pin number 1 to pin number 8. And the pin number 9 is reset. Pin number 10 to pin number 17 as mentioned in the diagram, port 1 and port 3 are available on one side. So pin number 10 to pin number 17 are port 3 pins. You can see 3.0, 3.1 so on up to 3.7. Similarly, other ports, port 0 and port 2 are available on the right side. So there you can see port 2.0 to 2.7 are available from pin number 21 to 28. Then from pin number 33 to 39 we have port 0. Here one point you have to remember while drawing is pin number 1.0 is getting incremented to 1.1, 1.2, 1.7. I mean port number is incrementing as the pin number is incrementing. 1 is 1.0, 2 is 1.1, so on up to 8th pin is 1.7. Similarly here 10th pin is 3.0, it is keep on incrementing. 17th pin is 3.7. Here also same 21, 2.0, 22, 2.1. Here also it is incrementing along with the pin number. But whereas here in this particular port 0, you can see it is reverse. Pin number 32 is 7, 33 is 6, 5, 4, 3, 2. So here pins are pin numbers are incrementing but port is decrementing. Port numbers are decrementing. So don't write 0.0 to 0.7. You write 0.0 here and increment downside. Okay, so that point you have to remember. And these all the pins which I have drawn here in blue color, this and this are called 32 input output lines. Just now you mentioned out of 40, 32 are input output lines. So they are arranged as 4 ports. And all the pins which I mentioned in the green color, VCC, reset, crystal 2 and ground. These are all like power supply pins and then crystal pins. Totally 32 plus these pins, it became now 37 count for us. And the rest of the available 3 pins, 29, 30, 31 are EA bar slash VPP, ALE, PSC and bar. So I can say that it's only 3 pins you have to remember in the entire 40 pins. So rest of the others are very simple. 32 are input output lines, they are arranged as 4 ports. Then power supply pins are 3, VCC ground reset, crystal pins are 2 and then left out pins are only these 3, EA bar, ALE, PSC and bar. Now let us see the description of all these pins. So first, as I mentioned, the 4 ports are I/O. So first port P1.0 to 1.7, that is pin number 1 to 9, P1.0 to 1.7, these are port pins which are exclusively meant for I/O operations. These pins are exclusively meant for I/O operations only. And coming to the port 2.0 to 2.7, they are meant for I/O operations and they have a dual functionality here. The dual functionality is address bus. Address bus is available in port 2. Similarly, in the port 0, this port 0 is exclusively meant for I/O operations. All the pins will work like I/O pins, and it is having address bus A0 to A7 and data bus D0 to D7. That means this port, these pins 32 to 39 will provide us three things. One is IO lanes, other one is address bus, and the third one is data bus. Okay, so these pins are said to be multiplexed. These pins 32 pin is said to be multiplexed. It is giving us port 0.7, A7 and D7. Similarly, 39th pin is said to be multiplexed. It is giving us port 0.0 and then A0 and D0. Okay, so these pins are said to be multiplexed. These pins are having dual functionalities. They can work like IO devices, IO pins, or otherwise they can also work like address and data pins. And coming to the third port, third port 3.0 to 3.7. So this is also same like others. It will perform IO operations. Along with that, it is also having dual functionalities. It can have other operations, like it will be useful for reading and receiving the data and transmitting the data. So these two pins will provide us serial data communication. These two pins will help us in transmitting and receiving the messages. So I can say that there is an inbuilt UART in this port 3. Microcontroller 8051 comes with an inbuilt UART, so that reading the data and transmitting the data will happen through these two pins. And it is also providing us external hardware interrupts. You can see here these two are the hardware interrupts. They are external hardware interrupts. Out of the 6 interrupts which are available in the microcontroller 8051, 2 are external interrupts. Others are software interrupts which are generated in the programming part. So those hardware interrupts are coming through the pins 3.2 and 3.3. And the next two pins are timers. Timer 0, timer 1. 8051 is having two 16-bit timers. They are available in this particular pin 3.4 and 3.5. And coming to the last two pins in port 3, they will be useful to perform write and read operations from external memories. So whenever we are connecting external memories to the device, we will use these two pins to read and write the data from external memories. And coming to this port 3 pins, what is the use of these 3 pins? But before that, let me explain you what is the purpose, maybe the design rule by Intel device. Why we have given port 0, port 2 on one side is this port 0 and port 2 together will give us address bus. Port 0 is giving us A0 to A7, the lower byte of the address bus, and higher byte is available in port 2, A8 to A15. So total address bus is available here itself on the right side. And data bus is also there here, D0 to D7. So we already know that in order to interface external memories to the microcontroller 8051, we require 3 buses: address bus, data bus and control bus. So because address bus and data bus are available on one side, it is easy for us to put another IC here and do the interfacing. Maybe that is the reason they have given 2 ports on the right side. And coming to these 3 pins, what is the use of these 3 pins is, so first pin EA/VPP. Let us see what is the use of this particular pin, EA/VPP. So if we are interfacing, say for example, external memories to the microcontroller 8051. So the microcontroller 8051, before executing the code, it will first check whether the code is there in internal memory or in external memory. It does not know exactly where exactly the code is located. So what it will do is, it will keep on searching for the code in the internal memory first. After searching in the entire internal memory, then it will search the external memory. So it's a waste of time for us. It should not happen. So as soon as I ask the device to start executing the code, it has to do it. Okay. So in order to provide such information to the device, 8051 microcontroller, that code is not there in internal memory, it is there in external memory, what we have to do is, we have to program this particular pin. We have to connect this EA/VPP pin to the ground, that is for 20th pin. If I connect this EA/VPP to the ground pin, 20th pin, then it indicates that we are using external access. there is a logic, there is a bar on the signal, so it will be selected. If I give it to the ground, it will, if I want to connect it to the ground, that means if I give a logic 1 to that pin, it will select VPP. Okay, so if I connect it to the ground, it indicates that external access. That means the code is there in external memory. Then the microcontroller will get clear information that it has to go to the external memory and search and execute the code from that. So if we are not using external memories, then we have to connect this particular pin EA bar / VPP to VCC 40th pin. We have to connect it to 40th pin. Then it will indicate that code is there in internal memory only. If this connection is not made, we won't get the output. Even though the program is correct, but if you won't provide this connection, you won't get the output in the 805 based designs. Now coming to the ALE, what is the use of ALE is, ALE stands for Address Latch Enable. This Address Latch Enable is useful to demultiplex address lines from data lines. This port 0 is multiplexed. There port 0 is giving us address lines and data lines. So if you look at one particular machine cycle in 8051, during the state T1 only address lines are available. During state T2, T3, T4 data lines are available. But we want both address lines and data lines. Okay. So the data lines and address lines are said to be multiplexed, and in order to demultiplex them, we will use this ALE. So we have to remember that when ALE is equal to 0, we will get address bus, address lines are available. When ALE is equal to 1, we will get data lines are available. This is one logic shortcut to remember that how the ALE is demultiplexing address lines from data lines. So in detail, I will explain you about this ALE, EA bar and PSEN in next video. But here let me complete this pin diagram with a small description of each pin. So that is about ALE. ALE is going to demultiplex address lines from data lines. And the last one, PSEN bar. As the name, the full form of this PSEN is Program Store Enable. So this, as the name only tells you, this pin has to be connected to one particular pin on the memory, especially ROM memory called OE bar, output enable. So if I connect this PSEN bar pin to the OE bar pin, then only whatever the program that is there in that particular IC will be enabled. Even though I indicated that code is there in external memory, it is my job to connect this PSEN bar to the OE bar. Then only that particular code which is there in that will be enabled. That's why this connection is very important. Program store enable needs to be connected to the output enable pin on the ROM memories. So that's about pin diagram of 8051. Thank you for watching, and feel free to put your doubts in the comment section below. Thank you.